All right, here we go. So, today we're going to go over implicit differentiation. All right, so what is implicit versus what is explicit? Okay, and just to make sure everybody is over 17 in here, right? All right. Okay, so here we go. Everything we've done actually up until now is been done explicitly. Okay, what that means is explicit means that we can define y by itself in terms of x without any trouble whatsoever. So this equation right here, that is an explicit equation. It means it's just out there. Okay, so y is defined explicitly as a function of x. Sometimes we have functions that it's very difficult to get that y by itself and define it explicitly by one variable. And when that's the case, it's like this: x times y is equal to 1. Even though that one would be easy to change to explicit, that one is a we would call it implicit. Okay, so y is defined implicitly by the equation. So when I think of implicit, I think of imply. It's like not as strong as me just saying it. So explicitly would be where I can just say it. Here it is in terms of x. Implicitly is where I kind of imply it a little bit. I'm not sure that's exactly where those words came from, but that's what I think of. So the implicit form of this above equation is x times y is equal to 1. And the explicit form would be y is equal to 1 over x. Okay, does everybody see how I did that? I just divide both sides by x and I can get y all by itself. That one, like I said, is pretty easy to do. The derivative of this, if I rewrite this as negative 1, x to the negative 1, I get dy dx is equal to negative 1 times x to the negative 2, which is negative 1 over x squared. Okay, so that's the derivative of that. All right, so when we have an equation that is in implicit form and we don't want to change it to the explicit form, we have to come up with a way to take the derivative of it. And that's what we're going to get into now. So here's an example. This one was easy to rewrite, but the one right here, this is a little bit more difficult to rewrite. All right, it's hard to get this in terms of y equals, and the reason is because I got y and y cubed. I could try to isolate y, but I still end up with y times y squared something. Okay, that one's hard to rewrite. Okay, if I were going to, I would probably have something like 4y minus 2y cubed is equal to 2 minus x squared. Okay, I'll rearrange it with algebra a little bit. Now what do I do? Well, I could factor out a y. Actually, I could factor out a 2y, and I get 2 minus y squared is equal to 2 minus x squared. Okay, so what do I do to isolate y? I mean, it's hard. I can't really do it with the algebra that I have. So in cases like this, we're going to derive things implicitly. Okay, so now I know that this isn't quite the way that I've taught you to do things just yet, but you'll see hopefully why we're going to do that in just a second, or why we're going to do what we do in just a second. Okay, this little term right here tells me what I'm taking the derivative with respect to. So it tells me basically what is my variable that I'm trying to say is changing. All right, and so the derivative of this, what I'm going to do to take this implicitly is I'm going to take the derivative of x cubed, just like I normally would, and that's 3x squared, and then I'm going to just write out, what did I just do? I took the derivative of x with respect to x, right? So this is dx, dx. This is the part that is new. And what is dx over dx? We're going to say that's 1. So this turns into 3x squared, which is exactly what we've always done. We've always had that as 3x squared. Okay, so not any kind of change when we're dealing with x. But what about when I'm taking the derivative of y, this y cubed, and I want it with respect to x? There is no x in that, right? There's just y's. So the way that I do this is I take the derivative of y cubed like I normally would. Okay, that's the power rule. This is going to be 3y squared. And then what did I just do? I took the derivative of y, but it needs to be with, it's supposed to be with respect to x. So this is dy dx. And I can't cancel that. So the derivative of y cubed with respect to x is 3y squared dy dx. Does anybody see what I'm actually doing here? This is y cubed. This is something cubed, right? And it's y cubed. I'm using the chain rule. And what I'm doing is I'm taking the derivative 3 times, put that y in, and squared, and then I take the derivative of y, which is dy dx. What has always been the derivative of y? If I had y is equal to 3x squared and I said take the derivative of that, what do I do to the left side? What have I always done to the left side when I say I'm taking the derivative? I make it either y prime or what? Dy dx. Well, that's what I just did. That's the derivative of y with respect to x. And then it's 6x. Okay? Let's look at C. Okay, this is the derivative of x plus 3y. So they're adding together, so all I got to do is take the derivative of each of them and then I'm good. So what is the derivative of x? That's 1, and it's times dx dx, plus, what's the derivative of 3y? 3, and it's with dy dx. So that I can send away. That's 1 plus 3 dy dx. Okay, that's an implicit derivative. Let's do one right here. Well, hang on. Let's do xy is equal to 1. Have we already done that one?
Yes.
We did. We're going to do it now implicitly. So this is the product rule. So this is x times the derivative of y, which is what? 1 times dy dx, plus y times the derivative of x, which is 1 times dx dx. So this is x dy dx plus y. So this actually turns into negative y over x dy dx. Okay. All right, moving on. Let's look at this one right here. Okay, that's the product rule again, yes? And it just says take the derivative of it. So this is x times 2y dy dx. Okay, so I just took the derivative of y squared, which is 2y dy dx, plus y squared times the derivative of x, which is 1 dx dx. So this turns into 2xy dy dx plus y squared. Okay, we'll get some practice on this. It's gonna take a little bit of practice. All right, y'all ready for some more? The next one down there, find dy dx. So this time it's asking a little bit more. It's not a verb anymore. This is a verb. It says take the derivative of that. This says find dy dx. What is it? Dy dx equals something. All right, so first step, what is the derivative of y cubed? 3y squared. And then what did I take it with respect to? Y was my variable. I took it with respect to x, dy dx. Okay, next part. Plus. What's the derivative of y squared? 2y. And what did I take the derivative of? Y with respect to x. Minus 5 times the derivative of y is... Say that again? That's right, 5 dy dx. Minus derivative of x squared, 2x. I took the derivative of x with respect to x. What's the derivative of negative 4? 0. Okay? So this turns into 3y squared dy dx plus 2y dy dx minus 5 dy dx minus 2x times 1. I'm going to go ahead and move that over. Equals 2x. The reason I moved that over is because it doesn't have dy dx in it. I want to get all of my dy dx's together. So you remember how our little party with our x's, how we used to like to get all the x's together? Now we're getting all of our dy dx's together. Same idea. Okay, factor out a dy dx. And I'm left with 3y squared plus 2y minus 5 is equal to 2x. Dy dx, if I divide everything by 3, y squared plus 2y minus 5, I get 2x. 3y squared plus 2y minus 5. What was the question?
Why does the
dx over dx, they're the same. It just kind of reduces to 1. So there's your slope. Okay, so different from whenever we can explicitly do this, what is my slope in terms of this time? X and y. You got to have both of them to do it. No, that's not too bad. So you have a great teacher. Well, was we're doing these two, I can tell you that much. All right. This time it says find the slope of this point for the equation, that right there. All right, so here we go. What's my derivative of x squared? What's the derivative of 4y squared?
Oh, that's 8y.
Dy dx, right?
Yeah.
Equals 0. 2x plus 8y dy dx. 8y dy dx is equal to negative 2x. Divide both sides by 8y. I get dy dx is equal to negative x over 4y. And that's my slope. And now they say, what's the slope at that point? So dy dx is equal to negative square root of 2 over 4 times negative 1 over the square root of 2. So dy dx is equal to, what happens with these two negatives? They cancel. That square root of 2 is, this actually turns into 4 over the square root of 2. So it's square root of 2 divided by 4 over the square root of 2. When I do my division, what happens to that? It flips, right? So it's actually square root of 2 times the square root of 2 over 4. What's the square root of 2 times the square root of 2? 2. 2 over 4 is equal to 1/2. So my slope is 1/2. Last one. Slope at this point, 3, 1, for this equation right over there. Here we go. This is 3 times, and now I got to take the derivative of all of this. So this is what? X squared plus y squared, all of it squared. Chain rule. So this is 2 times x squared plus y squared to the 1 times the derivative of the inside is 2x dx dx plus 2y dy dx, and that equals 100 times x times 1 dy dx plus y times 1 dx dx.
I'm confused on the 100 part.
I just brought the 100 out and then took the derivative of x times y. And now I've got to distribute that 100. Okay? I got to distribute that 100. I'm going to clean this up. I'll show you what I'm going to do. This is where, I have suggestions that I would do if I were you guys. So this is 3 times 2, and that's x squared plus y squared times 2x plus 2y dy dx is equal to 100 times x dy dx plus y. So that's just cleaned up a little bit. Now what I would do is I'd plug in the numbers very carefully. So this is 3 times all of this. What's my x? 3 squared, plus my y is 1 squared, times 2 times 3, plus 2 times 1 dy dx. And then this is 100 times 3 dy dx plus 1.
Wait, why is the x in terms of dy dx, not dx dx?
Where's that?
On the right side, 100.
Right here?
Yeah, go up one step. It says like it's x dy dx.
Because that's the product rule. So that's the derivative. It's x times the derivative of y. And the derivative of y is dy dx.
Huh.
Plus y times the derivative of x. So just be very careful. Like as you're be in the moment. The calculus moment.
That sounds like a good movie.
This is terrible.
Carpe diem.
I love it.
Good, thank you. All right, so let's clean this up. So this is 3 times 2 times 9 plus 1 is what? 10. Times 6 plus 2 dy dx, be careful on your parentheses, is equal to 300 dy dx plus 100. 20 times 6 is what?
120.
120 plus 2 times 20 is what? Equal to 300 dy dx plus 100. What is 3 times 120?
360.
360 plus 120 dy dx is equal to 300 dy dx plus 100. Moving that over, what is 300 minus 120?
180. Or negative 180. Because you're.
I'm moving it that way. 180 dy dx is equal to 260.
Yes.
When I move the 100 over here, I get, this is all algebra. I know it gets confusing, but it's what it is. Now divide by 180, and I get dy dx is equal to, let's see, those go away. I can divide both of these by 2. I get what?
13/9.
13 ninths. Okay, we're going to stop there for today.